Okay, so I think we're ready to start this month's webinar. So hello and welcome to everybody. My name is Marcus Doran and I'm the General Manager here for Rahi Systems in Europe. This month's webinar is in conjunction with our partners, Vertiv, who have a history in industry-changing solutions and a well-earned reputation for innovation around power. So power is the theme this month, and we're going to be focusing on rack power distribution units. What you're going to learn this month is how the design considerations used to maximize PDU value and utility, and how the progression of the rPDU technology has changed over time, and in what ways modularity can factor into rPDU deployments. As part of today's session, we're also going to look at the many industry challenges that are addressed, how to manage stranded power, also solving the common inability to view and manage the power chain, and understanding resource management strategies about efficient power usage. We're joined today by Justin Blumling. He's a product manager for Geist, which is a division of Vertiv. Justin has spent his career in the data center industry working for both manufacturers and value-added resellers in project management, sales engineering and professional services roles. So welcome, Justin. He's currently a product manager for Geist, Vertiv's Center of Excellence for rPDUs. Blumling is also a US DOE certified data center engineer practitioner and a graduate MBA student at Miami University of Ohio. So welcome again, Justin. And also welcome to those on today's call. Now, we'd encourage people throughout the webinar to submit questions in the chat box. And what we're going to do is come back to those after Justin's presentation. So now I'll hand it over to Justin, and thank you all for joining.
Hello everyone, thanks for joining us today. We appreciate your time. My name is Justin Blumling and I'm a product manager with Vertiv Geist. Vertiv, of course, is the artist formerly known as Emerson Network Power, and as a company includes many leading brands of data center suppliers like Liebert, Avicent, and Geist. It's under the umbrella of Geist that I am here today to present a short webinar entitled Power is Knowledge, rPDUs Revisited. To start us off, this is the fundamental question that we'll aim to address in the short time we have today. We know that rPDUs have been installed in data centers for decades, and they're an essential part of the power chain. They are the last mile in a very expensive power chain. But while rPDUs as products haven't changed dramatically over the last few years, there has been some critical evolution, and it's that evolution that we're here to explore in the short time we have today. So here's the agenda. We'll do the following. Number one, we'll compare the past to present with regards to rPDU models. We'll look at some of the business problems that today's rPDUs can help solve. And finally, we'll look to the crystal ball to see what future rPDUs will involve from the fit, form, and function perspective. Across most suppliers, the categories of rPDUs that you see in this matrix are consistent. The terms that they use for their product families may differ slightly, but most contemporary suppliers offer products that fall into these 6 buckets. And these 6 buckets become more intelligent and functional as we go from left to right within the matrix. As we start here in the input monitored in this green category within the matrix, everything to the right of this color, and including this color, typically includes an intelligent or a smart PDU. Once upon a time, many rPDUs were not smart. Many rPDUs look like this. A lot of people called them just simple strips, perhaps signifying a resemblance to commodity power strips that they were used to seeing in other applications. Fast forward to today, and you'll notice a pretty striking difference in the appearance of our contemporary PDUs. As the slide says, contemporary rPDUs have embraced color to illuminate power relationships within the data center. Those colors most often include the entire housing color or the entire chassis color. Like here on the left-hand side, we see red, orange, and yellow. The entire PDU, of course, is painted in that particular color. And this is often used to illuminate the redundant sources, like an A and B power feed within a cabinet. These colors can also go to illuminate or illustrate circuit relationships within the rPDU. For some large capacity rPDUs, 6 internal circuits are needed, and as we go up in capacity, you'll have more circuits. So it's important for load balancing to visualize those relationships so that no particular circuit within a PDU becomes overloaded or no particular power is stranded within that rPDU. In this case, the modern rPDU is very much like a map, and much like the visualization that we see here. And in providing a map, we're hoping to provide a guide to our technicians who have to commission and maintain hardware deployments. So in this example, we have alternate colors for both our A and B feeds. This customer in particular, as you can see, chose blue and yellow to designate their A and B feeds. And it's nice because these colors really contrast to the white-gray aesthetic we see from the racks, floor, and ceiling in this particular installation. These sources are easily identifiable. The colors really pop against that backdrop. In this example, the PDU housing is our standard black or gray that you commonly see, but each outlet is surrounded by a colored bezel. And as you notice, these colors here at the top and the bottom, those colors are mapped to the color codes at the circuit breakers at the base of the PDU. So as I mentioned before, when we work with higher power three-phase PDUs, load balancing is very important. So in addition to identification, this PDU comes with built-in load balancing as each outlet is connected to a different subcircuit within the rPDU. So built-in load balancing for this particular model. If we think about the business challenge that this particular theme, the rPDU as a map, addresses, it's associated to risk mitigation or risk prevention. As the slide says, human error accounts for 1 out of 5 data center outages. So providing color to power feeds and circuits is one way to minimize the frequency of someone plugging hardware into the wrong spot. The colors are a constant reminder to our technicians of where they are within the data center. And if those colors are repeated throughout the power chain as they go upstream from the facility, from the data center into distribution rooms or mechanical corridors or battery rooms, etc., I think the better chance that operator will have of success to prevent this type of outage that would be related to power feeds, etc. As we return to this slide, to level set here, we'll focus now on the intelligent categories in this matrix, like we talked about before, everything from the input monitored category all the way to the right-hand side of the screen. Intelligent PDUs have been sold for years, as the slide says, but 2019's intelligent rPDUs are distinctly different than, say, their late 2000 precursors. Continuing with that theme of intelligence, I would say that modern versions, today's power strips, are wiser than their ancestors of only a few years ago. One way that a PDU can be wiser in terms of its intelligence is allowing its users multiple network approaches or network strategies. So we've talked about 2 of them here, or listed 2 of them, one being fault tolerant. So a fault-tolerant network approach would say that if the third PDU in this daisy chain were to lose communication because its network interface failed, if I'm monitoring those PDUs, I wouldn't lose communication to everything downstream from it. So if this was a long daisy chain, I would still have visibility to the PDUs downstream. The network would self-heal in a way using a spanning tree protocol to capture the data from those downstream PDUs. So they remain, of course, online and monitored. In this daisy chain fashion, it also minimizes the number of network ports that a rPDU or rPDUs would consume on a presumably expensive network switch. In contrast to the fault-tolerant approach, I can also do kind of a cascading or master-slave type arrangement where I could designate this PDU as a master, and I can connect to a number of PDUs downstream from it, and I can monitor those values and variables through one IP address. So it often comes down to how a particular consumer of rPDUs interacts with his or her IT department. Is that IT department more concerned about minimizing network ports that a PDU would occupy, or PDUs would occupy, or is it more cumbersome to have to give a unique IP address to each one of these PDUs? That's something that would have to be done, the unique IP address, if I were to choose this fault-tolerant approach. So a wise PDU would give its users the option of how they want to manage the network resources. Continuing on that trend, whether I choose fault-tolerant or cascading, an intelligent PDU is going to consume network resources. And if it's going to consume network resources, we should ensure that the resources are used wisely, that it maximizes its own utility of being on the network. And one way a PDU can do this is by plugging in external sensors to help a user understand the wider data center ecosystem. So we know that power and cooling have a very close relationship and are intertwined in computing spaces. So installing temperature sensors to this particular PDU or environmental sensors would certainly add value to that particular user so they can see how power and cooling in their particular instance are interrelated. It helps the user better understand, again, what's happening in the facility. So in this case, to look at this particular image, to revisit this particular image, if this customer were to use this particular network intelligence card, it would be possible for them to instrument the entire row of cabinets. So they could daisy chain a number of temperature sensors from one port and run them throughout the row, and then be able to pull all of that temperature data through one network connection. So in that case, a wiser PDU, by definition, should support temperature sensors, but it shouldn't support just standalone sensor on a single rack. It should have built-in intelligence, embedded intelligence, to allow the user to get greater coverage over their computing environment. A wiser PDU also, through its embedded systems, should facilitate more than what we're used to from looking at a PDU's UI or web server. It's common across many manufacturers, like we talked about, to designate a master PDU here in orange and to capture data from downstream slave PDUs. You can see the daisy chains happening here. But as a master PDU, it becomes wiser when it allows for the user to have some input on the data it captures. So for instance, to allow user-defined grouping of slave PDUs, allowing users to create new categories or new calculations that would sum maybe this PDU and this PDU together to arrive at a total sum of, say, rack 2. Or summing all of these values together to arrive at something called total row power or total aisle power. On that same note, when that happens, you see not only individual PDU readings, but you also, as mentioned, capture totals, maximums, and minimums. And so we're not only interested in the individual readings per PDU or per cabinet, we want to understand power and cooling profiles across the entire space. Do I have hotspots? Do I have more dense areas and less dense areas? It's through the summation and these calculations of maximums and averages and totals that allow us as a user to get a better statistical grasp of the complicated ecosystem that we're working with. Finally, using the same graphic, we're highlighting another related component, a UPS or rack mount UPS here in the bottom in this blue circle. Rack UPSs are very pervasive in smaller IT environments, edge deployments as they're often called, and they are a vital part of that power chain, working in tandem to back up the power provided by the rack PDU. So since their work is interrelated, a wiser PDU, through its embedded systems and its UI, should allow some level of integration with the UPS so that I can see the values of a UPS in the same single pane of glass, if you will, as the values that are captured by the rack PDU, since they're related in that power 1 line. Continuing on the trend of intelligent PDUs, configuration and firmware updates are just a fact of life for intelligent PDUs. And in the past, both of these exercises were rather cumbersome. You'd have a technician going to each PDU with either a laptop and a crash cart connecting to each PDU individually, or you'd have to go to each one with a thumb drive to upload a config or to upload new firmware. A contemporary PDU, however, should allow for quicker configuration and updates. It shouldn't be a cumbersome exercise that you have to designate a tech to spend hours to do this. So starting first with the network card, if a network card in a PDU fails, and if something fails in a rack PDU, it's typically the network card or the NIC card. It should be painlessly hot swappable, so the power distribution to the unit itself should remain continuous, and I can simply swap the intelligent card for a new one. And finally, and as firmware updates become available, users should be able to do them in bulk. So they should be able to discover their rPDUs through a software utility and push out a firmware update or a configuration file to the many hundreds of deployed PDUs that they may have, and not have to designate resources to spend hours in a onesie-twosie fashion in order to make that happen. Of course, in the age of mobility, we believe contemporary PDUs should make use of mobile technology where appropriate. One case where mobile devices and their apps are a really nice alternative is to the old clipboard-style reports that a lot of people still do, where they walk around the data center with a clipboard, they press a variety of buttons on the PDU to get the relevant values, they write them down, and then they move on to the next cabinet. With this particular approach, you could scan the PDU to get the same information that you would get if you were just writing down values on a particular piece of paper with a clipboard. And then when you're finished, you can download that file that gives a nice snapshot of all the PDUs that you scanned, all the value that's captured, all the values that are captured with that particular PDU, and export that data to Excel, which of course then you can do the many wonders of Microsoft Excel. So it's a nice alternative to the sneakernet reports that are so common and a lot of users still undertake. To conclude this section and to tie it to a business challenge like we talked about doing in the agenda, contemporary PDUs provide a lot more value than their precursors, even from a few years ago. So the cost-benefit proposition today is stronger than ever, especially when we consider some of the enhanced monitoring, the flexible network approaches, the quicker configuration, simple firmware updates, amongst many others that we've talked about. It's a really strong value proposition that today's rPDUs provide, providing the cost efficiency that management and managers are looking for. Finally, in looking at the rPDUs of present, we'll talk about modularity and upgradability. There are a lot of, modular products in the data center, from modular cooling devices to UPSs. The rPDU, understandably, was one of the final products in the ecosystem to embrace modularity. And there are products that use that term modularity with a few different approaches. We talked briefly about hot swappable intelligence cards that can be replaced if they ever fail. Those same cards can be used for field upgrades of PDUs. So for instance, you can exchange a legacy card for a PDU that you bought a few years ago with an updated card that can provide enhanced functionality like some of the temperature sensor daisy chaining and such that we talked about earlier. And we can contrast that with a different take on it over here on the right, where you have PDU models where the PDU itself is essentially a modular bus bar, and a user can exchange different modules within the PDU to address different outlet types. So if the next tech refresh the user undertakes requires C19s instead of C13s, there's no need to rip and replace the entire PDU. A different module can be hot swapped, everything being touch safe, and you can have the right combination of outlets in the right rack location. So two different takes on the concept of modularity within rPDUs. In the near future, we can see this modularity taking a different flavor in the form of a power connector and a power cord. So as the slide says, modularity in a power connector to create a universal PDU across the globe with geographic specific power cables. And this is how that would shake out. If we look at the image on the left-hand side, we have a traditional PDU represented with three different variants. We've got a 16 amp, a 30 amp, and a 50 amp PDU. And the part number that a customer would order would of course include the physical PDU, its cord, and its plug. So essentially stopping right here. And if a particular end user has a mix of hardware or a mix of geographies that require different amperages that you see here, they're going to have to manage three separate SKUs. If we contrast that with the quote-unquote universal design on the right-hand side, you'll notice that I don't have a 16 amp, a 30 amp, and a 50 amp PDU. I have what's dubbed as a universal PDU. I have a unique connector that is affixed to the PDU. You'll have the female side affixed to the PDU. Then the male side of that connector will then be hardwired to whatever plug is required at the facility end. So either 16, 30, or 50. So the PDU can remain the same for each of these applications, and it will become whatever it's connected to. So it can simultaneously, not simultaneously, but for across different geographies, it can be 16 amps, 30 amps, or 50 amps, depending upon the needs of the customer and the power installation. So this slide shows some of the possibilities for this particular product. The end of this unique cable has some of the plugs that we're used to, like an L630 or a 50 amp California style plug or an L2130. But of course what's unique is the physical PDU, the box, the housing, the chassis can stay the same. To make it universal, it's constructed to handle internally with the breakers and the conductor sizing the maximum electrical configuration of the variety of plugs, and it can handle and be whatever variant it needs to be depending upon the geography that it's going in. So from an end user's perspective, if their existing PDUs are 30 amps, but the next tech refresh is going to be beefier and would require a 50 amp connection, just for an example, this physical rack PDU, assuming it still had the number of outlets required, could be repurposed. We would simply, since it's modular, once everything is powered down, disconnect this connector and this cable, and then reconnect the 50 amp plug and connector right to the PDU. And we have a 50 amp PDU that is appropriately sized for the next generation of hardware. The previous slide dubbed the PDU as a universal model, since it could be deployed in any power geography across the globe. But if we're thinking about universality in total, a true universal model should address both its input from that specialized unique connector we talked about and its output, the various outlets that provide power to the hardware. So if we look at the outputs or the outlets here, we can see how approaches have changed. We used to have three-phase banked receptacles. So you can see this is bank 1, bank 2, then identified by the colors here. And we talked before about the alternating receptacles. So we have 1, 2, 3, 1, 2, 3 that repeat throughout the chassis, and you can see that corresponding to the colors down here. So we've gone from banked to alternating, providing the virtue of inherent balancing. And finally, we can go take that a step further and talk about alternating universal receptacles. And that particular image shows an outlet that can be either a C13 or a C19, depending upon what the user requires. So you can see just by looking at these outlets and looking at these outlets that the outlet has the signature of both a C13 or a C19. So it's truly universal if it can be either one of those variants and can address either one of those plug types. So in the future, as we push towards the universal aspiration, we can provide our users some level of comfort in knowing that their projections and forecasts for the number of C13s and C19s don't have to be as spot on or ironclad as they used to be. There's some margin of error or room for error because each individual outlet on a PDU can be either one of those, address either one of those plug types. So the outlet forecasts, of course, don't have to be perfect. The management challenge addressed here is skew reduction. So if we think about some of our larger players out there in data centers, if we think about some of our hyperscale players, there are a lot of big companies that operate both on-premise data centers, and they also have co-location environments, points of presence in strategic cities throughout the country or the world. Those co-location customers have to cater to anyone who would come to them. So they have to cater their electrical infrastructure towards the most common deployments. Whereas some of those big providers, some of them will run 415, 240 volt power in their on-premise data centers because since they're so significant, the 2 to 3% savings that brings is actually a big deal to them. So they may run higher power that is traditionally international or European voltage here in the States at their on-premise, but they'll have co-location facilities that need to provide traditional 208 volt to satisfy the masses of customers they address. So in this case, the customer could supply the same PDU for both of those environments and just alternate the power cable. So again, there's a matter of SKU reduction and simplicity there that this universal PDU could solve, along with, as the slide says, differing hardware deployments and differing international electrical standards. Keeping the same PDU, the same physical box, is often a big value. To wrap up the presentation here, just a couple more slides. There's a lot of technology parity within the rPDU market. There are a lot of very good suppliers out there, and no one really has any proprietary level of kind of umbrella technology. Everybody makes switched PDUs. Everybody makes outlet monitored PDUs. So in the world of technology parity, in that competitive landscape, consumers of rPDUs, we believe, will gauge suppliers based on the resource requirements those PDUs require for both day one and day two needs. So some of those requirements are listed here in this puzzle piece, and we've talked about many of them. Provisioning, configuration, updating firmware, network management, all those play into the resources required, and each organization is a little bit different. But what these all get to is the heart of the argument is speed. A rPDU that is bought in 2019 and deployed in 2019 should enable a fast transition from the time it arrives at your loading dock to the time that it's installed in a rack and goes into production. So a PDU supplier that addresses each of the categories in this puzzle piece, we think will provide the speed of deployment that consumers demand in this ultra-fast economy, in this ultra-fast data center environment. So that's the final slide. I thank everyone for spending some time with me today. I really appreciate it. I hope you guys have a good day and a good rest of your work week, and make it a great one. Thanks, guys. Cheers.
Great, thanks for that, Justin. So we have a number of questions in the chat box, and thanks again to those who submitted the questions throughout the presentation. So Justin, the first question for you is, are the advanced monitoring capabilities you describe intended to replace monitoring software?
I think that's possible for some customers where the enhanced capabilities in the firmware itself could replace the need for a standalone monitoring software package. Again, I think it depends on the organization. We will continue to innovate within our particular product to make the devices themselves more intelligent, give them more features without requiring the use of an add-on software package. But there are limits to that. That can only go so far because you don't have a ton of horsepower or processing power within that individual CPU itself. So a server-based or a cloud-based monitoring package would always provide a bit more enhanced functionality, such as reporting and advanced logging that some larger organizations may like.
Question number 2, are the colored bezels that surround the outlets only used for circuit identification?
The colored bezels that surround the outlets are used for both circuit identification and for another key purpose. Their primary purpose is actually to serve as a locking mechanism. So it is a bezel that will wrap itself around the hood of a C14 or a C20 plug and hold that cord in place so that it doesn't become accidentally dislodged in the event that someone accidentally brushes up against it, and you have that inconvenience of a cord falling out unexpectedly and the downtime that could result from that. So its primary purpose is to be a cord retention mechanism that doesn't require the use of any special proprietary cords. Any off-the-shelf IEC cord would fit in that bezel and that bezel would secure it in place.
Question number 3, Justin, and one that we hear on many occasions, is how many PDUs can you daisy chain together?
The number of PDUs you can daisy chain depends on the ultimate network strategy, depending on the choice that we talked about within the presentation in the middle there. If we chose to set it up in a master-slave type arrangement where one PDU was the master and it connected to a number of downstream PDUs, the number of total units there is 50. If you wanted to use the fault-tolerant daisy chaining via spanning tree protocol, the number of PDUs there would be 40. And you can also have some combination between those two. A lot of customers like the approach where they have a 2 PDU arrangement within a given cabinet. One PDU serves as the master, one PDU serves as the slave, and then they use one IP address for both PDUs to capture data from both PDUs. So in that case, that's a 2 PDU daisy chain under one IP address that then repeats throughout the data center. So the answer is it depends on whatever architecture you choose.
And I think we've time for one last question, and that is, what percentage of 240 volt, 415 volt international power are you seeing in the US market?
As I mentioned in the presentation, we're seeing some large users go this route for some of their purpose-built on-premise data center facilities, if you will, because they're building at such a scale that the 2 to 3% efficiency gain from going to that higher power distribution actually makes a meaningful difference to them in terms of efficiency. So we're seeing some of those bigger users. There's hyperscale, those large enterprise financial customers or web scale type customers evaluating this and deploying this, but it's still, in terms of the overall market size, in terms of the overall number of PDUs sold, it's still a relatively small number, a small piece of the pie of the larger US market that we see.
Okay, so that brings us to the end of the Q&A session with Justin. I'd like to take this opportunity to thank Justin for his time today and also answering the questions at the very end. Also to our attendees, thank you also for submitting the questions during the webinar. And there's a couple of questions that we didn't quite get to, so we're going to circle back individually after this session. As we heard from Justin, understanding your power requirements within the rack or data center, it is a critical part of any IT project. And at Rahi Systems, we have the most experienced team of engineers in the marketplace to help advise you on the right power configuration, so please don't hesitate to ask us at any stage. You can visit our website for more information at rahisystems.com, or you can join us again on next month's webinar to find out more about the critical infrastructure solutions that we offer. So for now, I'd like to thank you for joining and have a great day.